Hopefully you've watched the video for 10.2, the lecture video. So now let's take a look at some examples. Let's start with this one. This is number 6 from homework. 4 to the 1/2 power. So they want us to rewrite this in radical form, and then they want us to simplify the radical. So remember, when we have an exponent that's a fraction, the numerator tells us the power, the denominator tells us the root. So we are taking the square root of 4 to the first power, which is just the square root of 4. And of course, the square root of 4 is 2. So we have to be careful because our rules of exponents still apply. On this one, they want us to use radical notation to rewrite our expression, and then if it's possible to simplify it. So it's 9m to the 1/5 power. Now, first looking at it, some of us might think that 1/5 applies to 9m. But if that 1/5 applied to 9m, it would be in parentheses. Remember what 9m means? It means 9 times m. So the exponent is only on the base that is directly connected to. So that's not what this means. So we want to take m and raise it to the 1/5 power. So m, we're taking the 5th root, and it's to the first power. So m to the first power. That's being multiplied times 9. So this is 9 times the 5th root of m to the first power. Okay, so let's look at another example. Let's do this one. Negative 27 to the 1/3. So here, we want to take the cube root of our base. Our base is negative 27, and we want to raise that to the first power. So technically, we could put the first power on the inside or on the outside, but since it's just the first power, we don't even have to write that exponent. So we have to ask ourselves, what number, when we cube it, makes negative 27? Well, the answer is going to be negative, because when we take a negative to the 3rd power, a negative times a negative times a negative makes a negative. And then we ask ourselves, what number, when we multiply it times itself 3 times, gives us 27? What number times itself makes 27? In other words, what number to the 3rd power is 27? And that would be 3. 3 times 3 is 9, times another 3 is 27. So negative 3 is the cube root of negative 27. When we deal with exponents that are fractions, it doesn't really matter where we put our power. Here we're taking the square root of 4, and we can either put the cube on the inside or we could put the cube on the outside, just not both. So if we put the cube on the inside, then that's going to give us a larger number on the inside. 4 times 4 times 4 is 64, and when we take the square root of that, we get 8. On the other hand, if we put the cube on the outside, we can take the square root of the base first and then raise it to the 3rd power. Well, the square root of 4 is 2, and then we can cube that answer. Well, 2 cubed, 2 times 2 times 2 is 8. So we get the same answer either way. Typically, if our base is a number, we put the power on the outside. If our base is a letter, we put our power on the inside. Some other examples, we're going to have bases with exponents multiplied together. And we just have to remember, what are our properties for exponents? If we're multiplying and our bases are the same, what do we do with the exponents? Well, we add the exponents. So this will simplify to x to the 1/2 plus 4/3. Of course, if we're adding fractions, we have to have a common denominator. So I'm going to come over on the side and I'm going to say, well, what do I get when I add those together? Well, our common denominator will be 6. How do we turn this denominator into a 6? What do we multiply it by? What do we multiply this by? Okay. On bottom, on the second fraction, we multiply it by 2, so we have to multiply the top by 2. So that makes 8/6. When we add fractions, we keep the denominator, add the numerators. So 1/2 plus 4/3 is 11/6. And we don't want to change that to a mixed number. We want to leave it as a fraction. This is the exponent, or the power. This is the root. So that's the 6th root of x to the 11th power. Let's see what other problems they have us do in my math lab. Our base is -16, and our power is -3/2. Now recall that when our exponent is negative, that negative tells us that our base is in the wrong place. This is not a fraction, but we could think of it as being a fraction over 1. So to make our exponent positive, we take the -16 to the 3/2 and we move it to the denominator. If there's nothing left on top, there's a 1 there. So now we need to take the square root of -16 to the 3rd power. And we're going to put a 1 on top. Wait a minute. We can't take the square root of a negative number. That is outside of our domain. So the answer to this one is not a real number. Why is it not a real number? Again, this has us taking the square root of -16. Just to keep from any confusion, this is not a fraction. I'm just separating these. So this says take the square root of -16 and then that raised to the 3rd power. Well, we can't take the square root of a negative, so this is undefined as far as real numbers are concerned. So we can't do that. This one, they just want us to write the exponent being positive. So we have 1 over q to the -2/3. To make the exponent positive, if it's negative on bottom, we move it to the top and make the exponent positive. And we put a 1 on bottom because everything from the bottom moved up. But if we're left with a 1 on bottom, we don't have to write the 1 on bottom. It's only when we have a 1 on top that we have to write. The internet's being a little slow. We did one like that. We did one similar to that, except our exponents were letters the last time we did one of those. Now let's do this one. Y to the 1/11 over y to the 1/22. So recall that when we're dividing and our bases are the same, what do we do with the exponents? We subtract them. We take the top exponent minus the bottom exponent. And if we're subtracting fractions, we have to have a common denominator. So if we do 1/11 minus 1/22, our common denominator will be 22. So the second fraction already has that denominator, but to make the first fraction have a 2 on bottom, we're going to multiply top and bottom by 2. That makes the bottom 2 times 11 is 22. The top 2 times 1 is 2. So when we subtract the numerators, 2 22nds minus 1 22nds. Well, 2 minus 1 is 1 22nd. And I don't think they ask us to change that to a radical. They just say write it with positive exponents. So that's good. Here they want us to use properties of exponents to simplify this expression. So let's do this one. So recall that when we have a product, that's a product because that's 16 times u squared. Each of those get our exponent. So 16 gets the 3/2 power, and u squared also gets the 3/2 power. So let's take care of the u first. If we have a power and that gets a power, remember we multiply those exponents. So 2 times 3/2. So the 2's cancel, leaving us 3. So that's u to the third. And then we're taking the square root of 16, and that's raised to the third power. So the square root of 16 is 4. So 4 cubed. We don't know what u is, so we can't really simplify u to the third, but we can simplify 4 to the third. 4 times 4 is 16, times another 4 is 64. So this simplifies to 64 u to the third. Okay, let's do maybe one or two more. Let's see. Let's do this one. Let's write it. So that's x cubed to the 1/2 over x to the 7/2. So we need to keep our order of operation in mind. There's nothing inside the parentheses that we can simplify. So we need to apply our exponents next. So we have this parenthesis raised to a power. And remember, when we have a power raised to a power, we multiply those exponents. Let's make the 3 a fraction by putting it over 1. That reminds us what's being multiplied together. We're doing 3 times 1 on top, and on bottom, the understood 1 times 2. So the numerator simplifies to x to the 3/2. The denominator is x to the 7/2. Now we can simplify this farther because we're dividing and our bases are the same. So what do we do when we divide and our bases match? Yeah, we subtract the exponents. So we take the exponent on top minus the exponent on bottom. Notice our denominators are the same, so we can subtract our numerators. So 3 minus 7, negative 4 over 2. So 4 divided by 2 is 2. A negative divided by a positive is negative. And they just want us to write this with a positive exponent, not a negative exponent. So if our exponent is negative, we can move it to the denominator, and that will make our exponent positive. Nothing left on top, so we have a 1 there. So that's how that one simplifies. So let's go to the last type of problem from this section. They ask us to use rational exponents to simplify this expression. If we try to do this, one thing we'll learn in the next section is that if our indices, if the index of each radical don't match, then we're not able to combine what's underneath, or not at least directly. But what we can do is turn each into x to a power, and then we can use our properties of exponents. That's x to the first power 1. For the next one, x is to the first power, and we're taking the fifth root. And for the third one, x is to the third power, and we're taking the 10th root. So now that we have x to the power, notice all of these have the same base. So we're multiplying with the same base, we add the exponents. So if we can add those exponents, then we're able to combine these. So 1/4 plus 1/5 plus 3/10. What will our common denominator be? What is a number that 4 goes into, and 5 goes into, and 10 goes into? 20. So we want to change each denominator to having a 20. So the last one, we would multiply 10 times 2 to get 20, so we would also have to multiply 3 times 2. To get 5 to be a 20, we'd have to multiply it times 4, so do on top 1 times 4. And 4 is multiplied by 5 to make 20, so multiply 1 times 5. So we changed each denominator to having a 20. Now that we have the same denominators, we just add the numerators. 5 plus 4 is 9. 9 plus 6 is 15. That reduces. 5 goes into 5 3 times. 5 goes into 20 4 times. So this simplifies to x to the 3/4. So that's simplified with an exponent, or if they want us to write this as a radical, we're taking the 4th root. Our base is x and our power is 3. So since our base is a variable, let's put the power on the inside. So either one of those, just depending on how they ask for the answer. As a radical, this, with an exponential, or as an exponential this way. So hopefully that will help make sense of